Alrighty, welcome to part two of the kidneys. We're just going to be talking about the concentration gradient of the loop of Henle, things like that. So, down this way you have the medulla, right? Up this way is the cortex, and normal osmolarity for a cell is 300, right? And for the blood is 300 milliosmolar. And so that's what the osmolarity is going to be. That's what the concentration of everything's going to be up here, higher in the cortex, where the blood vessel comes along here, right? There's the capillary, um, glomerular capillaries that offer filtration, and so things will get filtered, and those things will come in, and then because the PCT, right, is pulling so many solutes, and there's also permeability to water there, and so solutes and water gets pulled, and so if all of it's 300 there, then here in the PCT, it'll also stay at 300 because 70% of sodium is leaving, and that means also 70% of water is leaving. So there's no net concentration change, even though there's movement of solutes. There's things going out, but it's going to stay the same because water is moving as well. Okay. Now, as we, well, I guess let's pause there, right, and go over here to the ascending tubule, where there are other solutes going. And now the difference between the PCT and the P and the ascending, right, is that in the ascending tubule, there's no water permeability. And so it pumps solutes out like that, right? Sodium, potassium, 2-chloride channel. That's what it is. And that causes a gradient. And so as um, the filtrate goes up this way, right? It's going to be pulling it out. And so, and what's nice is that these pumps are pretty powerful. They can pump against a 200 milliosmolar concentration gradient. So it's it's pumping things out. It's pumping things out, and that will cause it down here to be 600 milliosmolar outside of the cell. And because it can pump so much, right? This filtrate turns into 400 right there, and as it goes up, it continues to decrease, right? 300, 200, eventually it gets to 100 up here on the DCT. And then the interstitial, it starts at 600, and then um, because like it can only pump against a 200 milliosmolar gradient, right? As the concentration decreases, then so does if the concentration in the filtrate decreases, so does the concentration in the interstitial fluid. So then it goes to 500 milliosmolar out here, and then 400, and then back to its 300 normal level, right? And so you see that 300 right there, where that's all 300. And these solutes will diffuse everywhere. And so not only is this concentration right here outside the ascending tubule 400 milliosmolar, but everything on that level of the medulla is also 400 milliosmolar. Okay? And then everything here is 500. Everything below there is 600. And and it's just because those solutes diffuse laterally very well. So that causes these concentrations to be made outside of the nephron. Now, that's all because of the ascending tubule. And that establishes the renal medullary concentration um, gradient, And the descending tubule then can use this gradient because as it goes down, right, the osmolarity outside gets bigger. And there's no solutes that move in the descending tubule. So only water can move. And it starts out at 300, right? And then as the filtrate moves down to 300, but then the water sees, oh no, there's a 400 milliosmolar here. I need to go help those guys out to even it out. So then the water will leave the nephron, and that will cause the inside here to then be equalize and also become 400 milliosmolar. And that will continue, and water will keep leaving. So then 500 and then 600, right? So that's that's why the descending tubule can work like this. And now what's really cool is it's called a countercurrent mechanism because the blood actually flows in the opposite direction. So the blood wraps around this PCT here, but then it goes over here and it wraps kind of like this around the tube. And so it actually goes through the ascending first, which is nice because the blood comes through and then it gets filled with solutes, right? It gets filled with so many solutes here in the blood. And then as it goes back and it can go to a descending tubule, then the that allows that concentration gradient to remain consistent, right? And so much water will then flood into the blood cells. Even though the interstitial space is so high, because the blood also just receives so many solutes, it can take up that water as well. So really an ingenious mechanism this way. God is very he's truly a scientist. It's awesome. Now, this allows the concentration, right, to continue. And so because concentration starts up here at 100, that gives us a lot of flexibility because then as it comes down this way, remember we talked about how there's ADH that can be released? And ADH allows for aquaporin channels to pop up over here on the collecting duct, and that will allow water to leave potentially if it wants to. And so you see, remember how how this gradient is here, right? This is the same concentration. So over here, down here, it's also 600. So that's awesome, right? Because it uses that same gradient to pull out a bunch of water if it wants to when it releases ADH. Um, and because it starts at 100 up here, that allows a lot of flexibility in terms of how concentrated we want the urine. And so because of this gradient and then the potential release of ADH, there can be really concentrated urine up to 600 milliosmolar, or there could be no, like very little concentrated urine as low as 100 milliosmolar if you chose not to have aquaporin channels here on the collecting duct. Okay, so that's that's the kidney, and that's all about that's really cool. And so you can see that if you got rid of the MK2CC channels, those things establish the gradient. So if you got rid of those, then the the nephron, the kidney would not work as well as it should, and it wouldn't be able to get pee as concentrated. And at first you're like, "Whoa, wait, what?" Like, if there's no solutes being pulled out, then wouldn't this 100 actually be 300? And that's true, maybe the first time around, right? But over time, as fluid keeps going through the kidney, these solutes, like these concentrations, will diffuse up and down, and they will kind of equalize. And then the only urine that you'd be able to pump out would be 300 milliosmolar because there wouldn't be a gradient anymore. Um, and so these little channels are really, really important. And this is part two of the kidneys. Let's go.